In this video, we will see the basics of setting up an environment for predictive analytics tasks in R. We will use a bunch of libraries. We will essentially base ourselves on the caret package. The objective today is to see how to do some of the pre-processing things like creating dummy variables, then how to apply caret and run a basic regression model, and also to see its output. So we can just set up the environment. We need the tidyverse, readr, caret, and then the dataset is contained in the MLB data package. We'll also use a library called fastDummies to create dummy variables, and broom to tidy up our output we get from doing regression. So I'll just run this chunk. And then we will work with the West Roxbury dataset. And the dataset is found in the MLBA package. It's called West Roxbury, so I'll just import this as well. And then as we see that we have 14 columns, we have 5,802 observations. And we have some factor variables. Right now they're coming in as character. So is remodeling recently done, or done earlier, or none at all. And then our outcome variable here will be the total value of these homes. So we can also look at the names of the columns in the data set. This names function just gives us a vector of all the names, another useful function. And if you want to have names in just as a vector or a column vector, T is for transposing. So if we transpose the name vector, then we get them as 14 by 1 vector in a column. And now we want to create factors. We will create a factor from the remodel variable, and we'll also level them as the first level being none, second level being recent, and then the third level being old. And now if we examine the structure of our housing, we see that our remodel has been converted into a factor with none, recent, and old. Another essential aspect of dummy variable of these qualitative variables that we can create dummies. In some algorithms, we will have to have explicit 0, 1 dummies for all of our character or factor variables. And we will use, there are several libraries to create dummy variables. fastDummies has a nice function called column dummies. Now, in column dummies, some of the key arguments are that do we want to keep the column, which is a factor variable from which we created dummy variables, and do we remove the first dummy to avoid multicollinearity? If we include all the dummy variables, that's called one-hot encoding. If we throw all of them in a regression-based model, we will have multicollinearity or dummy variable trap. So in a regression setting, we often remove the first dummy. We can remove the first dummy based on the value, or we could also remove the most frequent dummy. As I said, in the one-hot encoding, we keep all of those categories. So when we do neural network or other tree-based methods, we would not have to worry about multicollinearity. We can just do one-hot encoding, where we have a 0, 1 binary category for all of our factor levels. But in a regression setting, we want to have leave out one variable to avoid the dummy variable trap. So here, remove selected columns will not do that. It'll just create 3 dummy variables, but remove the factor variable from which we created the dummy variables. So now if we examine the structure of our housing, we will see that our remodel has been replaced by remodel none, recent, and old. And this is what we call as one-hot encoding. But in a regression context, again, we want to not only remove the column which we dummify to create dummy variables from, but we can also remove our first dummy. So if we run that, now we see that the resulting output has only the 2 dummy variables. We've removed the first level. We said none was the first level. So again, a combination of factor command to assign levels, and then using dummy columns function from fastDummies to actually create dummy variables. That's a really good combination. So always specify character variables using factor. You can specify the levels, and then you can decide to remove the first level or do one-hot encoding, and then remove the column dummy. So these two are really two very key arguments, especially when we have character data, which should be a factor data, and we want to create binary columns of all of those categories on that factor variable. Now, again, we will work with a static training and validation set. Here, suppose we want to split our data into training and validation. We can use this really useful command in caret called create data partition. So what this command really does is it randomly creates a vector of row indices where we want to keep the proportion to be 80% of our data. So it will take our full sample size and then take out 80% of that sample size and then randomly create a vector of rows totaling up that. It's also useful to specify what is our outcome variable. This is useful if we have class imbalances when we're doing classification. It doesn't really matter in regression setting, but it's again a good practice to have the second argument as our outcome variable. So instead of a list, we are getting vector. So if I examine this, this is essentially a vector of randomly assigned 80% of the columns from our data set. So this is what we will be using to index our training set. So now we can do indexing from our housing data frame 2. We are letting all these rows that came up in this as the training set. And then the remaining indexes become the test set. So now we have our training and our test data frame. Again, the training data set has 80% of our observations. The test data set has 20% of the observations. So just to recap, two really important functions. The first was how to create dummy variables from a character variable by first converting that into a factor variable, and we can specify the levels. And then the second very useful pre-processing thing is to be able to partition our data into the training and the validation set or test set.